Hi, my name is Tejaswai and my presentation is regarding database normalization and 1F, 2F and 3F rules. In this presentation, I will guide you through the fundamental principles of database normalization focusing on the first three normal forms 1F, 2F and 3F. Normalization. Database normalization is a process that organizes data efficiently to reduce redundancy, improve integrity, and enhance performance in data systems. It involves decomposing table into smaller units based on normal forms, each ensuring better data structure. In other words, data normalization is a symmetric approach to organize data within a database. Its primary goals are to reduce data redundancy, ensuring that the information is stored only once and to improve the data integrity, meaning that data is accurate and consistent across the database. This process involves decomposing tables into smaller or more manageable units based on the specific rules known as normal forms. Different type of approaches are systematic approach reduces redundancy, improves integrity, decomposes table. Understanding anomalies. Before going through normalization rule, it is crucial to understand the problem they solve. Insertion anomaly. Difficulty adding in new data without unnecessary entries. Update anomaly. Inconsistent data when updating redundant records. Deletion anomaly. Loss of required data due to poorly structured tables. The first and the foremost rule. First normal form or 1NF eliminates repeating groups, ensuring atomic values in the columns. Basically, 1NF rule is the most basic level normalization and sets the foundation of subsequent forms. Its core rule is to eliminate repeating groups within the table. This means that each column in a table should contain only atomic indivisible values and there should be no repeating sets of column. If you take an example, if an employee has multiple phone numbers instead of having columns like phone number 1 2 in the same row, each phone number should be in a separate row or linked through a separate table. Second normal form or 2NF removes partial dependencies by separating attributes that depend only on part of composite primary key. To achieve second normalization form, a table must be satisfying 1NF. Additionally, 2NF requires that the elimination of redundancy data by removing attributes that depends only on part of composite primary keys. A composite primary key made up of two or more attributes. If a non-key attribute is dependent on only a portion of composite key, it should be moved to a separate table linked by dependent part of the key. This process reduces redundancy and ensures that each attribute directly relates to the entire primary key. For example, the given table order details, order ID, product name, price. Consider following order details that includes not only order and product IDs but also product name and price. Here, order ID and product ID forms a composite key. Our product name and price depend only on product ID, not on order ID. To of to normalize This we split it into two tables: product ID, product name, price, order items, order ID, product ID, quality. Now product name and price only in the product table where they fully dependent on the product ID. That eliminates redundancy and improves data integrity from product information. Third normalization form or 3NF eliminates transitivity dependencies, ensuring all non-key attributes depend directly on the primary key. The third normal form or 3NF builds upon 2NF by addressing transitive dependency. A table in 3NF if it is in 2NF and all non-key attributes are directly dependent on the primary key with no transitive dependencies. A transitive dependency occurs when a non-key attribute determines other non-key attribute. The rule is to remove attributes that depend on other non-key attributes, moving them to a new table. This ensures every attribute in the table is directly dependent on the primary key, minimizing redundancy and improving data integrity. For example, initial table: employee ID, name, department name, department location. Yeah, but your department name and location depend on department ID, and department ID depends on employee ID. This is transitive dependency. To eliminate this dependency, we split the table. Split for 3NF. First step: employee ID, name, department ID, department ID, department name, and department location. We create a new department table to store department specific information, eliminating the transitive dependency in the employee table. Resulting 3NF tables: employee and department tables are now 3NF, as all non-key attributes are directly dependent on the respective primary key. Boyne's code normal form BCNF, a strictly version of 3NF, ensuring every determinant is a candidate key. Beyond 3NF, fourth normal form. While 1NF, 2NF, 3 are most commonly applied forms, higher forms like 4NF and 5NF exist, but address multi-value and joint dependency, but are less practical for real-world applications. Benefits of normalization: minimizes redundancy, saves storage spaces, and eliminates duplicate data. Improves integrity, maintains accurate and constant data. Easy maintenance, simplifies database updates and changes. Faster queries, smaller table leads to quicker data recovery. Conclusion: achieving 3NF is generally optimal for balancing integrity and efficient. However, normalization should always be approached with considering of real world of traits such as query performance and data complexity. In conclusion, database normalization is a crucial process for designing efficient and reliable database. While various normal forms exist, achieving 3NF generally strikes an optimal balance between redundancy and maintaining practicality for the most real-world application. Understanding the off-trade involves such as potential performance implications for increasing joins is vital for making informed decisions that best suit for specific application requirements, like crucial for designing contagious improvement optimal 3NF. Understanding the off trade. Basically, the overview is 1NF elements respond. If you come to the overview, Normalization is a process that organizes data efficiently to reduce redundancy, improves data integrity, and enhances performance. There are three types mainly: 1NF, 2NF, and 3NF. 1NF, first normal form, eliminates repeating groups, ensuring automatic values in the columns. 2NF removes partial dependency by separating attributes that depend only on the part of a composite primary key. 3NF, or third normal form, eliminates transitive dependency, ensuring all non-key attributes depend directly on primary key. Except this, there are two more forms, 4NF and 5NF, which are used to address multi-valued and joint dependency, but they are less practical in real-world applications. The benefits of normalizations are minimized redundancy, improves integrity, easy maintenance, faster queries, and the optimal form of normalization is 3NF. Thank, thank you for your time. Thank you for your time.